All right, so let's talk about lexical this and what the hell that means. Imagine that I have a user, let user equal first name Peter, and then I got the last name Smith, and then imagine that that object had a method called get full name. So whenever we want to get the full name of the user, we call the method, and then the method will return, unsurprisingly, the combination of the first and the last name. So let's pay attention to the syntax. Here I can type this dot first name space and then this dot last name, something like that. So if I now want to display the details of that user, I can do console.log and then user.get full name. So can anyone tell me what will this algorithm return? Peter Smith. All right, let's figure out. Yes, that's correct. And that's predictable. Yeah, I'm sure that most of you managed to figure out that that was the eventual outcome. However, if I ask you why, in other words, what's the value of the keyword this, also known as aka lexical this? What's the value of lexical this? Can anyone tell me? It's the user. That's correct, Panos. And why? Nice. Nice. I think in 2 years running Codely, I think that's the best description I got about lexical this, Panos. So, yeah. So, lexical this is, first of all, an object. Yeah? Many people running job interviews struggle to talk about weird things, right? So, first things first. Unless you do something weird, and Esteban will talk about that on Thursday, naturally speaking, lexical this is an object. So what's the value of the object? Lexical this refers to the object that invoke the function where we are using it. So where are we using lexical this? On the get full name function. Yeah. And now the question is, who is calling get full name? User. So lexical this points to the user. So this dot first name is the same as user dot first name, and this dot last name is the same as user dot last name. Does it make sense? Any questions, guys? No. Wait. That has nothing to do with prototypal inheritance. So we are not inheriting anything. We are just resolving the value of lexical this. So what is the value of lexical this? User. This dot first name is the same as user dot first name. Why? Because who is calling get full name? The user. Does it make sense, Minji? All right, so now let's present a different problem. Instead of one user, now I'm gonna have two users. Look, user 2, first name, Mari, last name, Williams, and then get full name is user 1 dot get full name. So, with a comma, of course. So if I do user 2 dot get full name, what will it print? why Mary Williams? Or that's interesting, guys. That's interesting. So Ian said Peter Smith, and Minji said Mary Williams. Minji and Adam, and what about Panos? Panos. What do you say? Okay, and then okay. So that's interesting. That's interesting because it's everybody against Ian, right? So Ian, can you argue why do you think the outcome will be Peter Smith? Yeah, definitely Peter Smith belongs to user one. But now let's revisit the definition of lexical DS. Remember, lexical DS is an object. That's the first thing. Yeah. So it's an object. And what's the value of the object? Lexical DS refers to the object that called the function. Which object called the function? Was it called from user1 dot get full name or user2 dot get full name? Yeah. Look at line number 15. Who is calling the get full name method? It's user2, right? Because of that, now lexical DS, it doesn't point to user1 anymore. Now it points to, here you go, user2. Because we call the method from user2. What we did on line number 12 is we created a reference to the get full name function. It is true that get full name function belongs to user1. However, we are creating a pointer. We don't copy the function, we're creating a pointer. So now we can call that method via user2 as well. Yeah? So now when we do user2.getFullName, lexical DS will refer to user2. What happens if I do user1.getFullName? What will that return? Now I will return Peter Smith. That's correct, Ian. I will return Peter Smith because, once again, guys, it's the same question again. Who is calling the get full name function? User1. If you want to get some details about that, you can always add some breakpoints, right? Let's do that. So remember, you can add a breakpoint by clicking on the red dot on the left hand side of the line number, and now if you go to run the start debugging or the shortcut, I'm not sure if I change it. It should be something like Command-Shift-Enter on Windows and Control-Shift-Enter. No, Command-Shift-Enter on Mac and Control-Shift-Enter on Windows. So if I run it, in theory, here you go. It takes a while, but you can see that's one of the reasons why I really like debugging using VS Code, because it just works, guys, without any surprises. So look, if I hover over the lexical DS, you see first name Peter, last name Smith. So it's definitely referring to user1. However, if I change the exercise by calling get full name from user2 instead, and I run it again, now you will see that once the code stops on line number 5, it's taking a while. Here you go. Once it stops on line number 5, then you can see that this time, in this occasion, now we point to the user2. Any questions, guys? Yep. Here we call the function in. So you want to call the function like that? That's interesting. What type of the? Okay, that's interesting. That's interesting. What will this algorithm return? An error. Interesting. That's a very interesting theory, Panos. Why an error? That's correct. That's correct, guys. What type of data, anyone apart from Panos, what type of data get full name is on user 2? That's correct, Minji. It's a string because now we are calling the function up front, right? It's a string with something like the value of the string will be Peter Smith, right? So here, because we are calling the function, essentially we're doing something like that. We are invoking a function on a string, which doesn't really make sense. So that should throw an error. Here you go. You see, user should get full name is not a function. If we just display something like that without calling the function, what will that display? That's correct. That's correct. That will display Peter Smith coding here, hard coded here, right? So that's which is a bit weird, but that's the technical consequence of introducing that change. Even though that doesn't sound any natural to me, I think that's a very valuable exercise, guys. From time to time, try to break your code, try to do weird things, right? Like as Minji said, what happens if I call the function here? I think it's a really good exercise to prove whether you really can predict the journey that your code will follow. Any questions? Cool. So let's complicate the exercise a bit. Let's have for now one user 1.get full name. So when we call it, that will clearly return Peter Smith. Here you go. But now I want to change the exercise a bit. Inside of the get full name function, I want to create a new user. Let me call it special user. Don't ask me why I selected that name. And the special user has a first name Anthony, and last name Smith again. Give me a last name, guys. I'm really bad figuring out these examples. Jones, perfect. Something like that. Yeah, Anthony Jones, for instance. All right, and now look, I return special user. Actually, I forgot to do. So I'm trying to figure out what's the best way of dealing with the exercise. Yeah, get full name, which is a function that returns this dot first name, this dot last name. So that's pretty much what we got before. You see now the main difference is when we call get full name on user 1, in reality that will return special user dot get full name. Yep. You see the difference. So now the get full name function is a bit more complicated. So what will user1.get full name return? So Minji said that will return Anthony Jones. What do you think, guys? Do you agree with Minji or not? Minji and Adam. All right, so let's try to analyze that answer. Look, we call user1.getFullName. So essentially, we're here, right, on the highlighted lines from 5 to 12, no problem at all. So now, actually, let's do something. Just to prove, to get a better feeling about whether that's right or wrong, look at what I'm doing, guys. I'm adding some breakpoints. Yeah, I think it's been a while since last time we played with breakpoints. So before answering before giving an answer to this problem, let's talk about breakpoints, because once again, I don't think we can solve the problem without having a good understanding about the execution journey. So, tell me, guys, what's the execution order? Who wants to start? There are 2 points on the last board challenge of the bootcamp that I got in front of me, by the way. So who wants to get 2 points on the last week of the course? Yeah, of course, me. 16. Yep. Yep. 16, 12, 5, 9. And that's it, right? Okay. What do you think, guys? So, Dan? Panos? Yep. Nine and 12. All right. Yeah, yeah. That's interesting, actually. So, Ian or Adam, whoever wants to go next. Ian? Sixteen, 12, 9, and 5. All right. And Adam? 16, 12, 5, 9. So you agree with Minji, Dan, and Ebrima, right? All right. That's interesting, guys. That's interesting because, we got 6 people and you provided 3 different answers. So, yeah, let me check if anyone gave the right answer. I mean, no one is massively wrong, which is interesting. No one said the first line is number 9, or not sure you remember, guys, but at the beginning of the bootcamp you said weird things, right? So today is definitely nothing is really crazy here, which is a good thing. So 16, 12, 16. That's interesting because I believe no one really gave the right answer. Right, Minji wants to change the solution. Say it again, Minji. 16, 5. That's correct, Minji. That's correct. So Minji, she doesn't get any points because she had to participate twice. But Minji is right, guys. Minji is right, and that's the important thing beyond the points, beyond the scoring. So 16, 5, 12, and 9. Why? I mean, let's run it, right? Let's run it just to prove it. So it's not just about my words. So the first line is 16, right? That's obvious. That's obvious. We first of all, we need to call the function. So that's the first thing. But then, guys, we call the get full name because we call the get full name. We need to, what's the first line on get full name? It's line number 5. Yeah. So this is where Ian, Ebrima, Dan, and Adam struggle. Yeah. So only Panos and Minji got the second line right. So look, you see, number 5. That's the first thing. We have to start executing the function. And now, some of you said that line number 9 will run before line number 12. Like, actually, that was only Panos. But that's wrong. It's the same process, Panos. So, all right, yeah, eventually, you're right, we'll call it number 9, but before running the function, we have to call it. That's why now the code will jump to line number 12. Here you go. And finally, the last stop of the journey will be line number 9. So, what happened on line number 9? Back to my original question. On line number 9, let's evaluate this line. So we got lexical this. Lexical this will refer to the object that called the getFullName function. This getFullName function. So who called that function? Was it a special user or was it user 1? Guys? Special user, that's correct. So if I hover, look, you see, if I hover lexical this, it points to the special user. In other words, this algorithm will return Anthony Jones as Minji and then Adam originally suggested. Actually, Minji, I'm going to give you some points because I think you gave 2 positive answers in the same exercise, so you deserve it. Cool. That's the way it works, guys. That's the way it works. Remember that lexical this refers to the object that call the function. Questions? All right, so then the very last question for you. You know that when dealing with JavaScript, you can have functions like that. Yeah? Actually, you may have noticed that some people there is a shorter way of running these functions, which is, look, by removing the colon. When you have a function inside of an object, you can do something like that. You see, probably you've seen that somewhere. That's the same thing. Yeah, that's a bit off topic, but let me display both alternatives. So when you have a function, I'm not talking about arrow functions. I'm talking about the classic methods. When you get a classic method, you can write it on the full way, or you can use a shorthand, which is, yes, oops, sorry guys, using the parentheses. Yeah. So line number 8 is the same as line number 9. So now my question is, apart from the classic functions, how do you know any other way of defining the function on line number 8? Arrow function, correct. So look, I can do that, right? I can transform my function into an arrow function. So what will this algorithm return? Will it still return Anthony Jones? Will it work? Okay. Guys, that's bold. That's very important. So are you telling me that just by changing from a classic function like that to an arrow function, this is having an impact on the functionality of my algorithm? Because so far, officially speaking, we thought that you could use one or the other without any side effects, without any consequences. But if what you are saying now, guys, is right, that's a bit dangerous, right? That's scary, because that means that, that it's not that trivial to decide whether we use one or the other. First of all, you are right. You are right, guys. Look, if I run the code, it won't return Anthony Jones anymore. Pay attention. Oh, what the hell? Now it returns Peter Smith. So the arrow functions are changing the behavior of your algorithms. Why? And this is very important. With the classic function, remember, lexical DS refers to the object that called the function. So what is the function? Get full name. Who calls the function? Special user. Then lexical DS points to a special user. However, if I use an arrow function instead, now it doesn't matter. It doesn't really matter who is calling the get full name function. When you use the arrow function, lexical DS is inherited from the parent function, from the parent scope. In other words, lexical DS won't care about who calls that get full name function. It will look up on the parent scope, which is the parent function. And because here we are using a classic function, then on line number 5, can you tell me, guys, what's the value of lexical DS on line number 5? That's correct, Minji. It's user1. Why? Because as we have a classic function, then lexical DS refers to the object that called that function. Which object called the get full name function? User1. So here lexical DS equals user1. Farther down, as we have an arrow function, that means lexical DS will inherit the parent one. The parent one is user1. So be careful, because when talking about lexical DS, we should be careful about the way we define our functions. Questions, guys? That's interesting. That's a really good question, Minji. That's a really good question. What happened now? What will this algorithm return? Undefined? Why undefined? Panos? So what's the value of lexical DS on line number 10? That's a brilliant answer. It's I'll tell you something. It's a wrong answer, but it's a brilliant answer. It's a brilliant answer. Let me tell you why it's wrong, and however why the answer is brilliant. It is wrong because guys, pay attention. This is something subtle but important. When you debug using VS Code, you don't have a browser. You are running the code in Node.js. The window object only applies to the client side, only applies to Google Chrome, Safari, etc. So if you copy and paste this snippet into DevTools, you're right, Panos. Lexical DS will refer to window. However, I don't have any browser. I don't have any window here. So does anybody know what's the equivalent of the global window object in Node? No one? Any clues? I'll tell you. The equivalent is something called global. So global is the global object in Node.js. So if I add a breakpoint on line number 12 and I execute this code, you will find out that Lexical DS, it's obviously something a bit weird, right? There is, there is nothing relevant. There is nothing relevant on it. But this is just because the way Node works. So this is pointing to the global object. Do we have any property called first name on the global object? No. Do you have any property called last name on the global object? No, not at all. So if we run it, as Panos originally suggested, it returns undefined. That's one Panos. I'll give you 1 point on the board challenge because I really like the way you describe the problem. Questions? I'll show you. I'll show you in a minute. Panos. I'll show you in a minute. Let's talk about popularity. Before that, just very briefly, just let me do that. So if we do that, what will this algorithm return? Mark Hilton. That's interesting. And that's a bit, I think you're right. Don't ask me why this is actually not happening. Let's try something. Yeah, that should return Mark Hilton because that's a global. Let's return undefined. Oh, I think this should be something on, that was a bit unfortunate example because now Lexical DS should point to the global object. That's interesting, but it's not happening. So what is Lexical DS pointing to? That's a bit strange. That's a corner case, guys, because we're dealing with a global object. I cannot tell you why this is not working. Maybe there's a policy on Node.js to block globals. I don't know. This is one of the things I told you before that is a bit hard for me because I'm not an expert debugging with Node. I'm being, historically speaking, debugging with the web browser. But actually we can just, because I'm not very happy with that outcome, let's do something. Let me go back to the web browser and I'm gonna run the same example in an environment where, historically speaking, we felt more, or at least I felt more comfortable. So let me go to sources, and then I'm opening a new. Probably I can replace one of the existing snippets. So let me zoom that a bit. So essentially what I'm doing here is I'm just pasting a new snippet, with the same content as we've seen before. So in theory, that snippet should return Mark Hilton. Why? Let's run it. You see, it works. So here in the web browser, it works. Why? Because first name. Do we have any let or any bar? Are we declaring line number 2 and 3? Are we declaring these variables? Not at all. We are not doing let first name, let the last name. In other words, when you do something like that, internally, JavaScript is creating global variables, first name and last name. In other words, that's the same as doing window.firstname and then window.lastname. It's saving the first and the last name variables into the window object. And that means that when we run this algorithm, lexical this will refer to the window, right? Obviously, it goes without saying this is considered an anti-pattern. Guys, you shouldn't save variables into the window object. That's why I didn't want to go that far, because that's not very clean. Why this is not a good pattern? Because the window object is global. Yeah, everybody has access to the window object, including, guys, the browser extensions. That means if you do that to save, I don't know, user details, on your team app you are working with the sign-in, right? Imagine that as part of the sign-in you decide to save user credentials on the window object. And imagine that you install an extension that is doing window.firstname equal whatever. Yeah, they can replace it. That's why it's not a good thing to play with the global object. Yeah? But technically speaking, that's the way it works. When using arrow functions, Lexical DS will always check on the parent scope. And if there is no parent scope, on the browser, the root scope will be window, and on Node.js, the root scope will be the global object. Yeah? Once again, it doesn't work on the backend, and I will investigate that, but I got the feeling this is because by default, probably Node is not allowing global variables. I told you that's an anti-pattern, so maybe Node is smart enough to block that by default. Yeah, something like that. So back to what Panos asked before. How typical is playing with the lexical this? Well, you've been dealing with that a lot on React. Guys, when you create a stateful component, do you remember when you do class movie, for instance, extends react.component? Yeah, and then you do constructor. So how do you declare the state, guys? Correct. Imagine that we are creating a click counter component. So here, as Ian said, you do this.state. You see? This. You refer to this. And now when you imagine that you have a button, and as part of your button, you want to increase the counter. So what you did here is you had an onClick method, onClick, and then if you remember, we did this.setState, something like that, right? Or this.state.count+1, something like that. So that's what you've been doing so far. Do you remember, guys, that at the beginning of the bootcamp, when we introduced stateful components, I told you you have to do this trick of the arrow function. Do you remember that? Because without this trick, it won't work. So now, hopefully, you will understand why. Because first of all, let me create a function called update counter to separate things a bit. So update counter will do something like that, right? So if I do this.update counter here, that won't work. This is gonna fail massively. And the reason is now, who is calling update counter? Yeah, it's obviously this. But the thing is, who is calling that method? This method is called by the onClick. It's called by React. React internally is calling that method. In other words, we've lost the control on Lexical DS. We don't know who is calling that function, because we don't know. We've lost the control on Lexical DS. If you try this example, you will see that Lexical DS, in this case, I think it's undefined. It's something we cannot control. However, when you do that, when you have an arrow function, then pay attention. Who is calling the highlighted code? Once again, we don't know. We don't know. We don't know. However, because we are using an arrow function, Lexical DS won't care about who called everything. Lexical DS will just inherit the parent, and the parent context is the class. That's why you've been using this trick so far, to keep Lexical DS under control. And that's the way it works. However, even though it's not that complicated to deal with Lexical DS, it's still a bit messy. And this is one of the reasons why we have hooks in React. You've been using hooks all the time now, right? So one of the main advantages of hooks is, hey, you don't care about Lexical DS. There is no Lexical DS, guys, when dealing with hooks, unless you do something weird. So let me rebuild the same example, maybe on top, using a hook. So with hooks, you'll build function click counter, and then you will do let counter set counter equals use state starting at 0, and then return button on click equals set counter plus 1. Something like that, right? So you see the example on top, obviously ignoring the simplicity, right? Because you can see that in a couple of lines, we've managed to solve a problem that it took us 20 lines at the bottom. But ignoring the number of code, the amount of code we have to write, ignoring that, beyond that, pay attention, guys. When you have a hook, you don't need Lexical DS, and that makes your life easier. Do you see any single reference to Lexical DS here? No, not at all. You know what they do, guys? Because I started working in coding in 2017. At that time, we didn't even have hooks. So we still have many class components. And from time to time, I refactor, I transform from classes to stateless, to functions with hooks. And one of the things I do to check if I did something wrong is I do Command F and I search for this, for Lexical DS. If there is any single reference to Lexical DS on my hook, on my stateless component, that means that I forgot to change something. Yeah? Obviously, that's not rocket science, but I think that's a good way to prove whether I managed to successfully migrate my component from stateful to stateless or not. So back to your original question, Panos. The JavaScript community tends not to mess around with Lexical DS because even though what we've shown today is relatively easy to control, in some occasions, when you have a function that calls another function, and suddenly arrow, and suddenly classic, and suddenly, it's just exhausting. It's exhausting. So if there is any alternative, and thankfully with React now we got hooks, then let's go for it. As you know, now we are introducing view training. And something I noticed is that with view, I don't think we have something similar to hooks. So with view, you still need to rely on the Lexical DS, and that feels slightly awkward to me. But anyway, that's probably a different discussion. So, questions? That's a good question. You know that there is Vue 3 being released shortly. And to be honest, I cannot answer your question. I don't know if Vue 3 is actually introducing something similar to hooks, but I wouldn't be surprised because definitely the React community is moving away from classes. Last summer, we ran, I think I mentioned that already, we ran a React challenge for senior developers in London, in Shoreditch. And, I think pretty much no one uses a class. Everyone use a hook. And this is once again because of two reasons. First of all, because of simplicity, but then don't underestimate. Don't underestimate how easy it is to do something like that by accident and then break your code completely. Anything else? Hello? Cool. So thank you very much for watching. Let's have a 5 minutes break, and then Dan, now you take control. So once you are ready, just let us know. Thank you, guys. Cheers.